In this video example, we will concentrate on a special and very powerful design option of OptiLayer. It's called Formula Constrained Optimization, and we will illustrate this option using high reflector design problem. This is the same design problem that was considered in Part 1. Our high reflector will operate in a broadband spectral range from 400 to 900 nanometers. We will use standard layer materials and glass substrate. And in the design process we will look for a design represented by a formula. It will be not conventional design, but a special design represented by a formula. Formula representation is one of the widely used ways to describe an optical coating. This representation, formula representation, was very popular in the past, but now, many people use also this representation. Optical thicknesses of the layers are expressed as fractions of quarter wave optical thickness, where lambda 0 is a central wavelength. Standard quarter wave mirrors provide high reflection zones, but the widths of these zones are not broad enough. This is a standard representation of standard quarter wave mirror. Lambda 0 is a central wavelength and lambda L on lambda U are boundaries of the high reflection zone. This formula estimates the width of the high reflection zone, delta, of the first high reflection zone. And in this expression, we can see the ratio between high and low refractive indices. For example, for standard layer materials with refractive indices 2.35 and 1.45 and central wavelengths of 650 nanometers, this is central wavelength of our high reflections range. The width of high reflection zone is approximately 200 nanometers. We need 500 nanometers. The high reflection zone of a dielectric multilayer coating can be broadened by combining a quarter wave mirrors with different central wavelengths. In our case, we have high reflection zone from 400 to 900 nanometers. We can use the formula from the previous slide and we can calculate widths of 3/4 wave mirrors. And we can find that 3/4 wave mirrors are enough to cover this high reflectance spectral range. It means that we need 3/4 wave mirrors. This is standard representation of a quarter wave mirror. And several match layers between these mirrors and on the boundaries with the incident medium and on the boundary with the substrate. All these parameters C1, D1, O1, B1 and so on are unknown parameters. These parameters can take their continuous parameters, and these parameters M1, M2, M3 are the number of pairs in a quarter wave mirror. These parameters are integer. The problem is how to find optimal values of all these parameters. But you don't need to think about this optimization process, about optimization of all these parameters, about how to find these parameters. OptiLayer will do it automatically in the course of Formal Constraint Optimization option. Let's open OptiLayer and we will see how OptiLayer will solve this complicated design problem. And we'll look for a special design structure. The target is already prepared. This is the same target that we used in Part 1 when we designed a conventional high reflectance coating. We can remind that our coating appearance in the spectral range from 400 to 900 nanometers. And target reflectance values 100% in the whole range. In the case of formal constraint optimization, it can be found here in Synthesis menu. We don't need a starting design, because all designs will be generated by OptiLayer Software automatically. We open this formal constraint optimization setup window. Here we can see our parameters. We can specify these parameters first, or we can specify first formula and then form our parameters. We have prepared these settings. We have filled the table. First of all, I specify the number of integer variables. It's 3. There are 3 variables, and they indicate the number of pairs in our quarter wave mirrors. And here we can see the boundaries, where these integer values can be varied. In this table we can see continuous parameters, A, B, C and so on, and lower and upper limits are between 0.8 and 2. So also, we have prepared this table. And this formula can be typed or it can be simply pasted from another software. For example, from a Windows clipboard basing on these three integer parameters, OptiLayer calculates the total number of all possible combinations. And it's easier to check that there are 10 possible values for all of three parameters. And if we multiply 10 by 10 by 10, we will get 1000 combinations. Of course, this value is important for calculations, because how many combinations OptiLayer will optimize? OptiLayer will try different combinations, try all combinations, and each combination OptiLayer will optimize the design with respect to these continuous parameters. But this can be done very fast. Now we can go to the next page and check again. These are our continuous parameters. These are our integer parameters. And then we press Apply and Run button. And here we can see a progress bar. We have 1000 combinations. So, we will need some time to finish calculations and to consider all possible combinations. Now, after some time we can obtain the whole collection of the designs. And all designs are arranged with respect to the merit function. So, the best designs are always on the upper part of this collection. We can switch between different designs. For example, 89 layers, 85 layers, 83 layers. We can take designs with smaller number of layers. For example, 69 layers, and so on. We can extract designs from the collection. Simply we can save a design that we like. For example, design 69 layers. Of course, here we can see designs which are not so good, with some peaks. But of course, it's up to optical coaching designer to select design that he needs. We can also open refractive index profile window and we can compare different designs. We can look at their profiles. And we can observe these designs and decide what design is the best for production.